Hello, and welcome to IP addressing worksheet number 2. In worksheet number 2, we are going to discuss IPv4 uh, classless and classful IP addressing. We're going to look at the 5 classes of IPv4 and look at how a router can identify the network address from an IP from an incoming package, so it knows where to send it to. It uses what's called a logical ending between the IP address and a subnet mask address. Okay, so let's begin. In the old days, routers, the way if a packet came in from outside and it had an IP address, because the IP address consists of 4 numbers, like 192.168.10.1, for example, 192.168.10, in this case, .135, out of these 4 numbers, some of these numbers are the network address and others are the host portion of that IP. So the router is only interested in the network portion of the IP address. And how does it know which numbers are the network portion and which numbers are the host? It really doesn't care which, because router is just interested in the network portion. So the way it figures that out, where they set it up, is they set 5 classes of the IP address. Depending on which class you are in, we'll be able to identify if it's the first byte, first, the first byte is the network address, the first 2 bytes, or the first 3 bytes. So the classes are classes A, B, C, and D. If your first number begins with 1 to 2027, then the first byte is your network address and the last 3 is your host. If the first number begins between 128 and 191, then it's the first 2 numbers is your network address. If the first number begins between 192 and 223, then it's the first 3 numbers is your network address. If your number begins with 224 to 239, okay, that's really not designated for not designated IP address for a host, but rather it's being used for multicasting. Okay, this is for a course that's a little bit beyond the scope of this course, and it's used for something like IPTV, for example. This is to be able to send a packet to multiple devices in a LAN. Not everyone, like broadcasting, just multiple devices. If your IP address begins between 240 and 255, then this is used purely for just experimentation over the internet. So the classes D and E are not assigned to any hosts, so no one can have this IP address and be able to communicate with them. This is really classes A, B, and C. All right, and there are restrictions in these classes as well, like the network address, the loopback. We'll talk about that on the next worksheet. So, for example, if an IP address came in from outside into a router, and the router needs to know where to send that IP address, so it needs to identify the network portion. So what it does is it looks at the first, for example, this IP address came in from outside. It looks at the first byte, and this number is 178. So 178 is a class B address because it lies between 128 and 191. Since it's a class B, that means the first 2 bytes, the 178 and the 16, is your network address, right? So the network portion is 117.16 and 178.16.0.0. We typically write 00, and we'll explain that later on. And that's your network address. The host is always written in zeros when you're writing the network address. The host portion then is 156.45, the last two bytes. Right, and that's it. Here's another example. 1256, 116, 210. Since 12 lies between 1 and 127, that's a class A. So class A says that the first byte is your network address and the last 3 is your host. The host in this case would be 56, 116, and 210. Okay. Now, that means your address, your network address can only be either 8, 16, or 24 bits. So that really restricted us. To be able to make it a little bit easier, wouldn't be give us more addresses. It would be nice if we can have a network address, for example, 10 digits, not 8 or 16. So what they did is they came up with the idea of a mask. Instead of having classes A, B, and C, so what we're going to do is if a network, if an IP, if a packet came in, so what we're going to do is we're going to pick up a mask that's going to mask the host portion of the IP, revealing the network address only. So that mask could mask as many bits as it wants in the host portion. So it doesn't have to be a mask that hides, for example, 24 revealing only 8, or hiding or masking 16 revealing only another 16. So we could mask, for example, 20 bits, and then the network address will only be 12. So that gives us more flexibility and more network addresses that way. So that's where the subnet mask address. How do we do the masking? The router actually takes the IP address and does a logical AND with the network address, or with the IP address, and the result will be your network portion of the IP. So the logical ANDing set means the following. For example, if we're going to do it bit by bit. So if you have a number such as 101111001, and you have another number underneath it, 11101110, and the way to do logical ANDing is if the two numbers that are aligned on top of each other are the 1 and 1, then the answer is 1. It's like a gate. It's a logical AND gate if you know electronics, which means if the two inputs are not 1 and 1, then the result would be a 0. So both inputs, 1 and input X and input Y, have to be 1s for the result to be a 1. So if the top and the bottom is not the same, 1s, then the result will not be a 1. So this one is 1 and 1 is 1, 0 and 1 is 0, this is a 1, this is a 1, this is a 1. And if you get 0 and 0, of course, it'll be 0. So the result will be this. So for example, if you want to AND 192 with 255, so all you have to do is just write the 192. Yeah, I'll do it on a separate sheet of paper. So if you have 192, I want to AND that with 255. So all you have to do is just write the 192 in binary. So it's 1100 and 1, 2, 3, 4. That's the 192. 255. This is from worksheet number 1 is 4 1s. So what would the result be? So when you have 1 and 1, so you have 1. Another 1 and 1 is, I'll just put it right underneath it so you'll see what I'm doing. 1 and 1 is 1. 1 and 1 is another 1. And then the rest, as you can see, because the top is 0, it'll be 0, 0, 0, 0, 0. So you get 192. So here's rule number 1. Whenever you ANDing with 255, you get the same number back. Okay? 192. If you ANDed 192 with 0, the result would be 0 in decimal, right? So if you have 192, which is 1 0, 1 1 0 0 with 4 zeros again, and a 0 decimal is what? Is 1 2 3 4, 1 2 3 4 zeros, and the result is going to be what? Oh God. It'll be, because you're ANDing 1 and 0, because the bottom is 0, the result, as you can see, will be 8 zeros, which is equivalent to a decimal of 0. Right? Ignore this. That would be the result, right? So, rule number 1. Anytime you AND with 255, you get the same number back. Anytime you AND with 0, you get 0 as the result. So, going back to our worksheet. So if you add 192 with 255, you get the same number. But here, the mask doesn't have to be all 0. So I'm ANDing with 224. 224 is 1150. So 165 ANDed with 224, you're only preserving the first three numbers. That's what the, all right. So you're only looking at the 10 and everything else would be a 0. So ending 165 with 224, you'll get 160 back. And that's where the masking does. Okay, so a logical AND is if an IP address came in with this and had a mask with like that, the network address is 192.168.10.160. So this packet, 192.168.10.65, with this mask belongs to this network address, 192.168.10.160. Okay. Now, sometimes we write this in a slash format, 255.255.255.24. The slash format means this actually has 8 bits, 8 ones, another 8 is 16, another 255 is another 8, which makes it 24. 224 right here has 3 ones. So this mask address has 27 ones. So we usually write, instead of writing this in, 3 255s and a 224, we write it as /27, right? So here's an example of /13. It's easier to write /13 than to write 255.248.0.0. So 255 is 8 ones, right? 248 is 5 ones, and then the rest are zeros. So this is how you would write your mask. Here's examples of the subnet mask addresses written in decimal format, and this is in the slash notation. It's easier than having to be classful, which means the old days routers have to figure out what class the IP address is in, and then trying to figure out what the network portion of the IP address, if it's the first byte, the first 2 bytes, or the first 3 bytes. Now, because if you have a mask, you don't even have to worry about what class the IP address is in. All you're going to do is take the IP address and then AND with the mask, and the result gives you what network the address is in without having to knowing what class the IP address is in. That's where the word classless came about. So, for example, if an IP address came in with 192.168.170 and it has /27, and someone asked you what's the network address of this, so what you do is you take the 192.168.170 and you end it with the decimal format. As we've said earlier, 192 ended with 255, you get the same address. 168 ended with 255, again, you get the same number, 168. 10 ended with 255, you get the 10. And the 70 AND with 224, you get 160. How do you do that? Well, I'll show you. You do that on the side. So 170, here, let's do that here. 170 in binary is 101, that's 160. So you need a 10, so you put a 0 here. And a 10 is 1010, 8 plus 2, right? What's the other address? I forgot. 170 ended with 224. Okay, so 224, then 224 is equal to 128 plus 64 is 192 plus 32 is 224. Perfect. So 0, and then you write 4 zeros. What's the result? Well, here's the result. 1 ended with this one is 1. 0 ended with this one is 0. 1 ended with this one is 1. And because the bottom is all zeros, the bottom 5, the rest, the leftovers are zeros, doesn't matter what's on the top. So you're going to get the result of 5 zeros at the bottom. So this is equal, if you convert this back to decimal, you get 160. So that's how you get that 160 at the end. Okay? And that's your network address. That's pretty much it. So now we're left with the exercises to play around with. So you can practice this. So if you're given an IP address, this is just, well, the old days, figure out what class this is in. Then by just looking at the class, this has nothing to do with ending. Figure out the network address, figure out the host. The subnet mask address, it either is going to be 255.000 or 255.255.000 or 255.255.255.0. That's it for this one. And the slashes are either going to be 8, 16, or 24. This part of the exercise is just practicing the IPv4 slashes A, B, and C only. All right, no ending or anything here. Here you do ending. So take this number, A and D with this number, find out what the network portion is, and then slash notation means I want the mask written in slash notation. For example, this is slash 24. This one is slash 16. This one is, for example, the fourth one down here is slash 24, and 240 has four ones. So 24 plus 4, that's 28, slash 28, and so on. This one, you got to be able to take this IP address, then take the slash 20, convert it into the decimal format like this, and then do the ending, and you'll get their network portion. So the first thing you're going to do is take the slash 20, convert it into decimal format, and then end the IP address with the decimal format to get the network address. Okay, so practice and let me know if you have any questions. Good luck, and I'll see you on the next worksheet.